Hello, welcome to this video of the Future Internet course. Remember that we are in the data plane programmability part of the course, and I will do here a very simple and brief demonstration of how the P4 language works. So this is very important, and you already have a virtual machine of P4, and there is a tutorial on how to deploy this virtual machine on your machines in the resources of the course. So right now here, I already have my P4 virtual machine open, and we will see the most basic switch that you can configure, a very basic switch that you can configure, that you can actually program in P4, okay? So here, if you go to the file manager of P4, you see these folders here. There is one called tutorials, and inside tutorials, you have another one called exercises. In these exercises, you have some exercises to actually work on P4. You can start looking at any of these exercises. Today, here in this video, we're going to do the most simple one, which is called basic. So we can go inside this basic folder, and you'll see that you have here a basic P4 file, a make file, and a README file. This README file will tell you how to execute the uh, the switch that we have here, and this basic.p4 is the file that we are going to work in, the one that we are going to modify. And this is actually the P4 code of a very simple switch. But also in this basic folder, you have here a folder called pod topo. In this folder is very important because it shows you the topology that will be simulated in Mininet using the switch that you're going to deploy, right? That you're going to configure. So this is the topology. It's called podtopo.png. This is a topology which is formed of 4 hosts, host 1, host 2, host 3, and host 4, and 4 switches. All these switches will work, or will be the switch that you're going to program actually in P4. All these switches will be basic switches using the basic.p4 file, right? So here you can see we will maintain this window open, the IP addresses of all the hosts and the ports of all the switches and how they are connected. Also here, this is very important, you have some JSON files with the rules that are already, let's say, hard-coded in the switches configuration, but the switch should know how to apply these rules, and that's why you need the basic.p4 file, okay? So here in the topology, and the JSON file of the topology, you have the definition of all the hosts with the IPs of all the hosts and the MAC addresses of layer 2 addresses of all the hosts, right? So this is the IP of host 1, which is 10.0.1.1 of host 2, 10.0.2.2, and so on for all the 4 hosts. So you can see that each host is in a different subnetwork, right? The switches, if you go to the switches, they say, okay, you should go here and run this code on each switch. S1.runtime, S3.runtime.json, S4, and so on. And here you find the links that you have in the network, which are, and you can check that the links that we can see here in the figure. So if we go to the each switch runtime, this is actually the rules in the switch. So you will say that the target is a BMB2. This is the type of switch, of virtual switch, that is able to receive P4 programming files and then configure the switch taking into account the file. Okay, then here you have the table entries. So this is very important. This switch will have tables of the type myingress.ipv4 LPM. We will define this kind of table then in the basic.p4 file. Okay, the actions will be also defined there in the basic.p4 file. And these are the parameters we have here the table, then we do here the match. So for instance, for this switch, when the destination address is the host 1, which is 10.0.1.1, then I do a match in this table. And then I put the action that I will do. The action here is my ingress. It's called IPv4 forward action, and I will pass a parameters to this action. And the action then will be performed. But the definition of the action, so what the action does is actually defined or described here in this basic.p4 file. Okay, we will see that later. And this is done actually for the action for the host 1, the host 2, and the host, all the hosts. So if you see here the action for host 1, for instance, so if the destination address of the packet is 10.0.1.1, which is host 1, then I will apply the IPv forward action with the parameters destination address, this MAC address, which is the MAC address of the host, and the port from which I have to send this for in this packet if I am switch 1, right? If I am switch 1 and the packet is directed to host 1, I will send the packet through port 1. So I have to define the action on how to actually do that. Okay, and this is the same for all the other hosts. So the actions here are pre-charged, are charged here in the JSON file. So the switches already have the, let's say, the tables filled with these match and action rules. The same will be, you can check, but the same is done for switch 2, for switch 3, switch 4, and so on. Okay, so now the important thing is to see, to look at the code of each switch. So we're going to explain this in detail. Let's see. Basic.p4, this is the code of the switch. Okay, first, I just have here the libraries that are included. I define a constant, which is type IPv4, the type IPv4 that you normally find in the Ethernet headers. So in the Ethernet headers, there is something called Ethernet type, and it will say if it's going to have IPv4, ICMP, or IPv6 in the layer 3. The type of IPv4 is this one. So I will define the constant, right? Then I will define 3 variables. One is called egress spec T, MAC address T, IP address T. This is the type of MAC address, IP address, or egress specifications. We're going to see that in a minute. So remember that last class, I told you that the first thing to define in a P4 program are the headers that you're going to recognize from the packets. So this is a very simple switch. We are just going to recognize up to layer 3 and just IPv4 headers. So I am going to just recognize Ethernet headers in layer 2 and IPv4 headers in layer 3. Okay, so my header in my Ethernet header will have destination address, which is the type. The type of this address is MAC address T that I define here. So I said that this destination address should have 48 bits, right? And the same with the source address. And I will have a field called Ethernet type, which is the one I already told you. If the layer 3 of the packet is IPv4, IPv6. So this is a normal. These are the normal fields of an Ethernet header, and I will define here as Ethernet T. This is my header. Then I go to the IPv4 header. So my header IPv4T will have all these fields. All these are the normal fields of an IPv4 headers. Version, the HL, differentiated services. We don't need to understand each field. It's important just to know that each IPv header has all these fields. You can go, of course, to the RFC of IPv4 to understand each of the fields. It's not necessary here now. The total length, the identification, the flags, the flag offset, the time to leave, which is a very important parameter, the protocol of the upper layer of, if I am talking of TCP or UDP in the transport layer, the checksum, the source IP address, and the destination IP address. And I am telling them that this of type IP address that I already defined here, right? And here. And I will tell all the other fields how many bits I am expecting these fields to be. Okay. Here in the headers, you also define the metadata of the packets. This is going to be a very single switch, very simple switch. Sorry, so it's not, we are not going to use the metadata, and we are going to create an struct saying that the headers of the packets that I am going to recognize will be Ethernet header and IPv4 header, and so my switch will recognize just these two kind of headers. Okay. Then remember that I have to go to the parser. So first I define the headers, and then I will parse anytime each parse the headers. Okay. So here I will have some to-dos, so some code that should be, actually this basic is an exercise, so this is the code you have to fill in each part, but I have their answer, let's say, commented here. So here in my parser, in the parser, I will receive the packet, right? This packet in, this is the packet that I receive. The header, the out headers of the packet, the metadata the packet has, and the standard metadata the packet has. Remember that we are not going to detail metadata in this simple example, but this is important, very important to see. For instance, the port from which the packet entered, the at which the packet arrived to the switch, and so on. So I actually encourage you to look at the other examples to actually see how to use the packets, the metadata fields. So the first state of the parser, the first thing that the parser does is always the start state. So here in the start state, I have to add the logic of the parser. So my parser, I have this line commented, but what I will do is to transition to another state, which I will call parse Ethernet. So please go and parse the Ethernet header. This is the idea. So I will go to the state parse Ethernet, and I will say, okay, I will extract from the packet in the headers that I received from the packet, I will extract the Ethernet header. Okay, I remember that in the struct, I define the Ethernet header here as Ethernet. So I will, from headers, extract the Ethernet header. And I will select, I will do a transition, right? So I extract the header and I will go to other state. The other state is, of course, to extract the IP header. So, okay, I will extract the Ethernet header and I will do a transition based on the ether type field of the Ethernet header. Remember, we have this ether type field that will tell me what is the protocol of layer 3 that this packet has. But here I will just parse IPv4 protocol, right? So I will say, okay, let's transition to another state. So if the type of this ether type is IPv4, so let's go to the parse IPv4 state. If it's not IPv4, so by default I will say accept, so the packet will be processed without looking at the layer 3 header. Okay, but if the packet, the type is IPv4, I have to extract the headers of the packet. So in my parser, I will have all the headers of all the packets. So the parse IPv4 state will extract all the headers of the IPv4 layer and then transition to accept. So what I have now is all the exact fields of the Ethernet header and the IPv4 header already for me to do the processing or the things I want to do, right? So remember, first I define the header, then I do the parser. Then there is one a step that we're not going to fill here, but normally you have to do a checksum verification. So you have to verify that the packet that just arrived is not damaged. So the checksum of this packet is the one that it should be. But we are not going to apply this step because we are, as I said, doing a very basic switch. So please, again, I encourage you to go to the other examples to see how the checksum verification is done. Okay, so here we are just going to have an empty apply. Then we do the, let's say, the most important part of the switch, which is the ingress processing. Okay, so I have these headers of Ethernet, I have these headers of IPv4. What should I do? What kind of tables can be applied in this switch? What kind of key I can put for the match? What kind of actions can I permit in the switch? So this is the idea. So I will have here a control, let's say a structure or a control a structure here that has to be defined. It's normally called my ingress. In the ingress processing, I will have the headers of the packet. I will have also the metadata and the standard metadata, which in our case is empty, right? So I am going to say some things, okay? So one action will be called drop, so I can drop the packet. This is an action that I am going to define. So drop is an action, and when I drop, I just call this mark to drop, which is a standard function with the standard metadata, which will mark the packet with a drop in the metadata. Okay, so the switch will know that this packet will be discarded. Okay, this is a standard function of P4. But I also have to define the action to forward the packet. So I will call this action IPv4 forward. This is a very important action. This action will receive the destination MAC address of the packet and the port by which I will send the packet. Okay, so the destination address and let's say the egress port. This is going to be received by the action IPv4 forward. This is the name of the action. So here I have this code commented, but this is actually the code that I will apply. This switch is doing IPv4 processing. So what the switch will do is, okay, to the standard metadata of the packet, I will add to the egress specification the port. So I will let's say mark in the metadata of the packet, which is the port from which the packet will go out. Okay, my packet will change, right? If I am doing an IPv4 processing, and so I will send the packet from the switch to a host or to another switch or whatever, right? I have to change the MAC addresses. So the source MAC address of the packet will now be the address of the switch, right? Which was the destination address of the Ethernet packet before. So that's why I update the source Ethernet address of the packet with the destination that it had before. And the new destination address of the packet will be the one that is received by the IPv4 forward action. Okay, so this is the destination address. And another thing that you do anytime you process an IPv4 packet is to decrement the time to live. Remember that normally the time to live is 16, so the packet cannot do more than 16 steps or traverse more than 16 hops. So I have to subtract 1 from the TTL. So the TTL is updated with TTL minus 1. Okay, so these are the actions that I propose, and these are the only actions that can be applied because the switch will just have these two actions: drop and IPv4 forward. And what is the table that I will have? My table will be called IPv4 LPM. LPM is longest prefix match, which is the way to make match over IPv4 addresses. So the key, so what is the key? The field on which you will do a match is the destination address. So I will do a match on a destination address, and the type of match that I will do is a longest prefix match. So that means if I have an IP of a host which is with a network mask 32, it will do the longest prefix match. So it will choose the subnet that is closer to that IP address, right? So what I am saying in the table is that the match will always be done with this key. So the key will be in the destination address, destination IPv4 address of the packet. So you will do the match always there. And the actions that you can apply is IPv forward, drop, or no action. So you have these three possibilities to put when you fill the tables of the switch. So here I'm defining what kind of tables you can have and what kind of how you do match on these tables and actions on these tables. This is the size of the table, so the number of entries that the table can has, and the default action is no action. So is if nothing happens, if you cannot do any process, so you don't have to do any action. Here you have the apply. In the apply is when I can apply or when I can use this table, and the table is only used if the IPv4 address is valid. This is also this is valid. It's also a native method of P4, but you can also implement this kind of methods. So if the IPv4 address is valid, so you can apply the table IPv4 LPM. Okay, and in the egress, this is in the ingress processing. So when the packet arrives to the switch, I do this, so I can do a match with this kind of table, and I can do this kind of actions. The egress processing is what to do when the packet is going to egress. So if you want to put it in some queues for quality of service or things like that. And this is important, but right now we are not going to do anything, any further processing when the packet is going out. Again, if you can look on how to define this egress processing, you can go to the other examples. So after this is done, and the control routine is called my egress, but I don't do anything. I just put apply here, an empty apply. Then we have something called the checksum computation. So you have to, again, as you changed some fields of the packet, the checksum, of course, is different. So there is one method called one control routine called my compute checksum that receives again the new headers of the packet and the new metadata. Then you do something called the update checksum, which is an already defined function of P4 that is done only if the IPv4 address is valid. And then what you put here is just all the different fields of the IPv packets, right? And you say that you please calculate the checksum with this field with this hash algorithm, and this will put the new checksum in the packet. So this is done. This is normally by default. So every time you have to use this same my compute checksum control routine. Okay, and then you go to the parser. So when you parse, you first parse the packet, and then you, let's say, deparse the packet, you put again the fields in the packet and send the packet. So the control my deparser a routine just does something called packet.emit, which is put the new Ethernet header and put the new or the modified IPv4 header. And these are all the let's say steps that you have to do for a basic switch. So this B1 switch, then you put everything in order. First, you put my parser, then my verified checksum, my ingress, my egress, my compute checksum, and my deparser. And this is the main. So all these functions that we saw, all these control routines are placed in order here in the switch. And in this way, you define the switch, and that's it. So I know that maybe it was very fast, but I encourage you to go again to this code and try to see it in detail. Okay. So again, if you go here, let me show you. Let me try to put this tuple here. If you go here to any JSON of these switches, what they have, they use the table that we just defined. So for instance, this switch number 1 will use the my ingress IPv4 LPM table. You will say the default action is true, the action name is drop, and the action params are nothing. Again, these are the entries of the table and when the packet is dropped. But for instance, when I have a match here, right? Remember that the match key was the destination address. So when the match in switch 1 in destination address is 10.0.1.1, so I am referring to host 1, the action name here, okay, is IPv forward. So I will forward the packet, and the parameters that I pass to the action, remember that the action that we define here, let me go here, will receive the IPv4 forward action will receive the MAC destination address and the port from which by which I will send the packet. So I will say, okay, the action parameters are the destination address is this one. So this is the host, this actually MAC address, and the port by which you're going to send the packet is port 1, right? So what I am doing here is filling the tables in the switch, but I just defined what kind of tables is my switch able to receive in this basic.p4 file. This is very important, okay? So in this way, I can define any table, any field of the switch that I want to manage, and so on. That's why I can actually program the data plane. Good. So here I will go to the terminal, and I will let me go to the tutorials, exercises, and basic. So I will to the basic folder, right? So I'm just here in this folder, right? If you go and read the README file, in this file, they will tell you how to run the switch. It's not difficult. It's just you make the bash command and then make run, and it will open the mininet topology with all the hosts and switches that you had, right? With all the rules also that you had. Remember that I had in my switch code, I have all these fields, all these code lines commented. So if I want to do an HP from host 1 to host 2, I will not be able to do the ping because my switch is not actually creating the tables and so on. So I will close this here, okay, and I will go to the basic.p4 and I will just delete the comments of the code. So in the state start, I will delete this comment. I will delete these comments here in the action, which are very important, right? The action IPv4 forward. I will delete the comments. Where else do I have comments? Here in the packet meet. Let me check. Just say that, let me check that I don't have any more comments. I don't think so. Okay, and then I will run this again. I will run the bash again and then make run to open the mininet topology with the new basic.p4, right? Which is the file that the switch is going to have. And now I can, without any problem, think because all the switches will be working with the code of basic.p4, so I can do anything that I want to do. Okay, this is very important. So this was the first example of P4. We're going to have a lab very is going to be a basic lab also of the second example that you can see there, which is called basic tunnel. So thank you very much for watching this video, which is a little bit longer than the other ones, and I hope it was a good introduction of P4. Thanks a lot, and I wait you in the next video where we're going to start the part of artificial intelligence in networking. Thank you very much.